In order to get an intuitive feel for perpendicular lines, it helps to start with a pair of lines that you know are perpendicular. So the diagonals of a square are going to be perpendicular, and this square that I've kind of outlined here has two diagonals drawn. Now watch what happens as we rotate the lines. Since the lines are rotating at the same rate, they remain perpendicular, and eventually it's going to get to a place where we don't necessarily know if they would have been perpendicular or not, especially at the very get-go. So as the blue line keeps rotating and rotating, the relationship remains the same. They're still perpendicular. But here at the end, if we would have just been given this, we wouldn't be necessarily sure that these two lines are perpendicular. And what we're going to do first is we're going to analyze these two lines and prove that they are in fact perpendicular before going forward and looking at how we can apply this knowledge to equations of lines. In order to help us see the relationship, I've drawn the slope in for the original lines, which the first blue line had a slope of -1 and red had a slope of 1. But a lot of people think that, oh, you just make it negative and then all of a sudden they're perpendicular. In this example, you can see that it's not true. The blue line has a slope of 3/5 as you go up 3 and over 5, whereas the red line goes down 5 and over 3, so it has a slope of -5/3. And so you see that just making it negative is not enough. You actually have to flip the fraction, or as we say, take the reciprocal. So here I've drawn in the angles in the triangle, and we don't know exactly what the angles are, so I can just label the smaller one alpha and the larger one beta. Notice they're the same triangle, just rotated a little bit. Now to see how this helps us, if I were to draw the same triangle, or just imagine rotating it so that it fits right in here, this is my right angle, and alpha is the smaller angle, so it's going to be down here, and this is beta. You might already see that this makes a rectangle just to prove that it is going to be a right angle here, or just a right angle here whenever we have alpha and beta together. But let's just look at this a little more mathematically. I know that alpha plus beta plus 90 degrees equals 180 because these are the angles of the triangle. Therefore, I can say that alpha plus beta must equal 90 degrees just by subtracting 90 on both sides. So now I'm positive that I have alpha and beta, that this must be 90 degrees. So now that we have that, and we know that perpendicular lines are going to be perpendicular if you take the fraction and you take the reciprocal, you're flipping it, and then you take the opposite sign. Let's look at how we can use that in a problem. So if I look here at an example where now we have a graph that has a line and we want the line to be perpendicular to this graph. So the question is, how can I use that knowledge? Well, first of all, if I know what the slope of this is, then I can just figure out the negative reciprocal and know the slope of the perpendicular line. So here I see that it's crossing the y-intercept at the point where y is equal to 3. And then it's crossing down here where x is -4. So this tells me that my slope, I'm going up 3 and to the right 4. So the slope of my original one is 3 over 4, which means that my perpendicular slope, the perpendicular slope would be -4/3. And depending on where I want it to cross, it's going to change obviously what my intercept is. Let's just say we want it to cross at the y-intercept here, or in other words, where x is 0 and y is 3. Now that I know my slope and I know my intercept, I can just write the equation of the line. So y equals -4/3 x plus 3 is perpendicular to my original line. And if I start at my 3, which is here, and I go down 4, 1, 2, 3, 4, and over 3, 1, 2, 3, I see that my line is going to be perpendicular. Now it's a little bit hard to draw in there, so you have to use your imagination, but you can tell, yep, that looks pretty perpendicular, and in fact that's always going to be the case. So the nice thing about it is, if you know the slope of this original line, either it's given in an equation, maybe the original equation, well I guess here the original equation is y equals 3/4 x plus 3, so either you can identify it from the equation, or you can count down and over on the graph to figure it out. Then all you have to do is take the negative reciprocal to figure out the slope of the perpendicular line.